ratings. Yeah. Please go on. Yeah, please go on to the next slide.
No, sir, no problem.
Yeah, as we have discussed, switch to LED lights, and we have covered thermostats. How do we, control through windows and doors, and look for energy ratings. Please move on to the next slide. Who's sharing the screen? Can you move on to the next slide, please? Yeah. Okay. This is a simple calculation that I've brought in here. We also should consider, based on the house that we live. So generally, when we look at this, yeah, we calculate the area of a house, and something that is being exposed is what should be considered in calculating the heat loss perimeter. In this case, can anyone calculate what would be the probably I'm sure you would have seen the answer already, but if somebody hasn't looked at it, can you tell me what would be the heat loss perimeter by looking at this diagram? Okay, so if you have already looked at the HLP, which is a 18 meter, can someone explain why is it 18 meter here? I'm sure you're all uh, from a science background. Should the area be calculated as a whole, or just if you look at this HLP, it's 6 meter and then 9.5 meter and 2.5 meter, which equals to 18 meter here. Shouldn't that be 6 meter, 9.5 plus 4.5 meter? Can someone say why it is not 20.5 and why it is 18? It may work differently in India, but this is how it is generally calculated in UK. But looking at the area, but probably you can tell me why it is not 20.5 and instead we have a 18 meter. Okay, what is generally a heat loss? How does that happen? Okay, so I mean, rather than to drag the conversation, let me put it this way. The main area would be considered for the calculation based on the area that is open for the heat loss. And extension is something that would be excluded. So if you look at this is something that is open, though there is an extension in the backside of the house. The open area for the main is for the main building is a 2.5 meter. So that should be considered. And then this is something that is open for the heat loss, 9.5 meter, and then the frontage is a obviously it's open 6 meter. So if there is a party wall which is mentioned as a PW, party wall is something that protects the heat loss. So the calculated value here is 2.5 plus 9.5 and 6. So which equals to 18 meter here. Yeah. So we all need to, work out how heat can be lost in a property or how that can be saved. Yeah, we all need to consider this factor. Yeah, please move on to the next slide. Yeah, this is something, dense urban or urban terrain. You would see all the nice buildings of London. And yeah, London city is urban terrain. Yeah, that probably, probably the city over there is improving as well. And yeah, you do have a lot of, buildings similar to this. Yeah, terrain type is generally recorded in a survey to determine the average wind speed at the property, which can then be used to calculate the benefit of a wind turbine. Depending on the area, generally there will be EPC ratings that would be done by the assessor, and whether it's urban terrain or rural terrain, they will assess and then come up with the rating for the particular property. So let's say if a property does not have a wind turbine, the terrain type must still be recorded in order to calculate the potential savings of installing the wind turbine for recommendations. Dense urban area, as you have seen, area with closely spaced property over 4 floors. And I'm sure you would have heard about Shard, one of the tallest building in London. Yeah, and you would see that yeah, all the areas around there, Bullet Building, all that would be part of the dense urban. And low-rise urban or suburban, this usually relates to most properties in towns and cities. And I've picturized them as well in the next few slides, where you would see several well spaced and neighboring properties. Rural is something that is remote. Most of the manufacturing sites, all that, are built in a rural city, and plants are also built in a rural city. Yeah, for example, if you take a Ford manufacturing plant, it's built in a outside of a city. Yeah. So this refers to properties neighboring areas of open land. Yeah. And terrain type is a again geographical feature, building location feature, which can affect an EPC recommendation of a wind turbine for a property. Here, the ratings are done by a EPC assessor, and I don't know how does that work in India, but we have ratings for all the properties here. If somebody wants to buy a property or rent a property, we need to, as per the government regulations, we need to have this rating in place, EPC rating in place, in order to sign up the property. Please move on to the next slide. Yeah, this is something rural terrain. You would see the difference between urban terrain and rural terrain, and this is all how it looks in a part of the UK. Yeah, generally we are going to discuss about how the building structures and dwelling forms are here. This is something called as a detached house, and I believe it's the same in India as well. If it is not attached to any of the other buildings or something, and which stands alone as a detached property, and there is a significant heat can be lost in a detached property rather than some property with a terraced with a party wall and all that. So if you look at this particular house has 4 heat loss walls and no party wall. Party wall is something that we have seen in the previous slide, and we'll be discussing in the upcoming slide as well. So what we could sense is detached property lost a lot of heat than the property with a party wall. Yeah, I'm sure you would have seen these kind of buildings already, but this is something called as a mid-terraced property. a property that is one of a row of identical houses. More of all these houses are identical, and this is in a row. These are called row houses. And one advantage of being in a row houses, you would be paying a less electricity bill than being in a detached house, because the heat loss wall, it's all a party shared with other property. So if you look at this, it has two party walls and two heat loss perimeter wall. Where yes, in a detached house, you would have seen the four, four way of losing the heat. Yeah, obviously, buying a detached is quite expensive when compared to the mid terraced. Yeah, and this is something an example of a enclosed end terrace, wherein you would see one that is between the other two houses. It's an enclosed mid terrace, and the one that is at the end, it's called an enclosed end terrace. So all these are generally considered for calculating the energy performance certificate. Yeah, example of end terrace property. As you see, it's a first or last property in a row of houses. It has three heat loss sites and one party wall. So as you can see, when you compare with the other two houses that we have discussed, young terrace is something that loses heat only on the one side of the property. So it can be either this property or the one at the rightmost will be losing energy at the on the end of the wall. Yeah, that's in the picture shown here. It's 1 and 4 or the end terraced property. This is again, yeah, as you can see, Bangla is much similar to of losing heat as of the detached house, whereas in flat and masonite, as you can see, it has a party wall. Yeah, this is something a simple count of the number of habitable rooms in the dwelling. Habitable rooms is generally it includes a living room, sitting room, dining room, a bedroom, study, and similar. The count of habitable rooms excludes, hall, stairs, and landing, all the other ensuite and similar. Where there are open plan rooms, count as one room, lounge and dining room without a door in between. See, all these are to be considered again for the EPC rating, energy performance rating. Conservatory is something, as I have shown in the previous slide, something that is extended from the back of the property. So that adds to the habitable room count if it has an internal quality door between it and the dwelling. Otherwise, it wouldn't be considered for the rating. It depends on how that is built and what kind of a quality door has been done on that. So that, yeah, please move on. So again, I don't know how does that work in India, but here, as a energy assessor, they need to consider a lot of things. There are two differences. One is related to the houses, and other one is related to the commercial. All that we have seen today is more related to the houses, and the property type would be captured, and number of stories, habitable rooms, and heated habitable rooms. All those would be considered when they are calculating ratings. Go on, please. So now, again, given a fair insight on the difference between the houses and then different urbans that we have over here. Yeah, move on. Yeah, again, system built construction. It involves making building components offsite in the factories and then bring them on for an assembly in order to build a home. So this is something that quite fascinating in the abroad, and it's catching up in the developing countries as well. And yeah, it can be a steel frame, prefabricated modules or blocks, or can be a concrete panels of various sizes. So this is slightly different from what we have discussed in the previous slides. And this has its own advantages and disadvantages too in terms of heat loss and how the energies are being calculated. So this is timber frame wall. Mostly you would have seen in the 80s, 90s movies, and it has a big history. So yeah, timber frame construction is normally visible outside in the form of timber. If you look at the Scotland, Scottish Highland, still these are retained there. They would even maintain 200 years of history by retaining, by renovating. They wouldn't yeah, destruct a building and then construct a new one. They would still maintain with the same timber frame wall. So these are some examples of usually how buildings are pre or early 900 built. These are something that you would find in a place like a Cotswold, wherein you would find stone walls and then the sand limestone. And these are not generally residential places, but it's all a tourist kind of a place where these are still maintained with sandstone and limestone. Okay, this is again something to be considered for the rating. We have an option to choose what type of walls are they, depending on the building that we are assessing on the energy. Yeah, modern timber frame is something that is catching up recently, and it is completely different from what we have seen in the 1900, and the variation that we have since 1960 has been changing drastically, and few people are considering having this kind of timber frame too. Yeah. Okay, solid wall insulation is something by looking at the building, we would know like how this has been insulated, uh, and whether it is protected from the outside or between the brick, whether the insulation has been done properly. When we are assessing the home, right, all we would be looking at is from the outside, but all these things will be recorded. And if you look at the example shown here, there is a brick there, and insulation has been kept along with the brick. And then this is again for bringing up a heat to the house, as well as during the summer, even if you turn on the AC, you wouldn't lose a lot of cooling temperature outside the house. So all we need to ensure is how these loft insulation is being done as part of the when we are constructing a home. That's quite important. And as you have seen on the right side of the slide, how it was before without insulation, and how does that look after the insulation. So by looking at the property outside, you will be able to see. But for a wall and the bricks inside, we won't be able to figure out by looking at it. But all those would be recorded, and as a energy assessor, they would be asking for all the recordings in order to rate the particular property. Yeah, case study is something that all these are something that we have discussed in all the previous slides. And these are something nowadays a lot of software companies are coming up with their own software for the energy assessor to use, and then take recordings based on the property. All we are discussing here is more of a housing property rather than a commercial one. This might slightly vary for a commercial property, but much yeah, similar to what we are discussing. Cool. This is something that I have highlighted. Slightly, this may vary in warm countries like India, but typical slice glazing is. Can someone tell me, if you look at the property over here, can someone tell me what type of glazing is it? Okay, please go to the previous slide. Can someone tell me what kind of glazing is it? Yeah, fine. So this is something, this was quite common in the earlier centuries, and now recently most of the houses are all triple glazed is what we have. Even in my house, I have a triple glazed windows. Please move on to the next slide. This is something that is called as secondary glazing. When an independent glass panel is installed, if you look at it, the one that is highlighted there, before an existing single glazed window, it makes the whole window a secondary glazed window. The one that is highlighted on the blue, right, that adds a secondary glazing to it. So in the previous property that you have seen, you would have seen most of it with a single glaze. And yeah, this is something that represents the second glazing. Secondary glazing is, yeah, sometimes installed, but double glazing is not permissible. When you look at the double glazing example, you wouldn't see the panel, the additional panel that you're seeing here. So that's the one difference. But government has a lot of regulations to allow whether property can have a double glaze or not. Then, depending on that, result, regulation result, we would go with a secondary panel if you're not able to fit double glazed one. Yeah, this is something that is, very important to be considered. If you see a space bar there, a lot of the engineers that when they fix it, if they leave a gap there, there is a chance of losing heat. You would be turning on the boiler for a lot of time. Even the whole day, the boiler would be turned on, but all of a sudden you would feel the coolness at home, and you would be wondering uh, how this is being lost. And the reason for that would be if there is a gap in the glazing that they have done, you would lose heat. And we should be very careful in fixing this, and we should have the right engineer to fix this. So there are recommendations in the options that is provided, as you see a 6 mm, 12 mm, and 60 mm or more, depending on what kind of windows we have at home and what kind of glazing that we have at home. This might vary, and yeah, and this needs to be taken care as well. Yeah. Yeah, this is something they have a set of standards here. Is mostly for a UK based. We have a FENSA certificate, and whether the property is built before 2002 or after 2002. Yeah, there are a set of standards that needs to be followed in order to ensure that we have a proper yeah, installation. Yeah, again, if anyone looking at the left thing, we would immediately think it's a door, but it's generally a window that we have, which may connect to either to a conservatory or the extension that you do at home. It's a proper window. And the one on the right, it is something, a door. The extension can be done in different ways, whether you can have a conservatory or you can have something like a built with a brick and then have a door similar to that. So yeah, these are the external doors in a property. Yeah, so again, percentage of multiple glazed windows. This is something assessor would know. Okay, what is actually from generally from India. If you look at it, you might think it's a door, but it's a window. But assessor, energy assessor would know whether it's a window or a door, and then whether it is properly glazed, whether there is a double glazed or triple glazed, and they would rate it accordingly with the calculations that they have. Yeah, this is a front and rear view of case study. That's again EPC is something, energy performance certificate. There is again a age band for conversion of unheated buildings. So when a unheated commercial building, let's say commercial buildings are born, farm building, train station, and similar, is converted into a residential property, the age band should be selected same as the conversion age. So let's say something that was built 70 years ago, and the train station is being converted into a apartment residential, and then we tend to buy that property. Let's say we buy it in 2025. We all think it's a very new property, and but when an energy assessor comes, he looks at when the train station was established. Let's say it was in 70 years back. So the age of the property would be given as a 70 years old property, though it is something that you have bought in this particular 2025 year. So yeah, that is something that needs to be considered. These are again some samples of how the buildings are in between 1930s and 1949. If you look at it, full bay windows, 40s cavity wall with 250 thickness, and then yeah, semi-detached. Semi-detached is something. Looking at this, you would know it's not a fully detached. It's a semi-detached one, and yeah, chimneys, shared chimneys. Obviously, houses here mostly have a front gardens, and most cavity wall, but solid was still available till early 40s or something. Okay, so coming back to the heating system, a system that provides heat to our living place, called also called spatial heating. And as I've been telling, referring to this mostly, it's a boiler here. It's called a boiler here, and there will be a main heating system. You would see all kind of a provision in the living room everywhere, in the bedrooms or all most of the areas at home here. And the main system is generally one that would be described as central heating. Yeah, central heating is something that is mostly in the living area. The heater, sorry, a heat generator providing heat to several rooms via a heat distribution system, although the term does not include, for example, storage heater, fixed direct acting heaters in each room. So there will be in every houses, yeah, there will be a area considered for the central heating. And second main heating or additional main heating is something other than the the main areas where the heating is given. We have given provision for the heating. Those are called a second main heating. Yeah, community heating is something that different from the houses that we have seen. It's as a more of a apartment community building where we have a common heating for all the houses. Though the apartment will have a specific energy meter for the heating that they do it inside the wall. There will be a common space area wherein the energies are, energy bills are shared across all the residents in the particular building. And there are many common areas, common boiler for all the shared areas in a building like this. So each houses will have a different boiler, and there will be a common boiler as well for the whole building. These are the type of electricity meters that we have, much similar to what you have in India. And the latest one would slightly vary with all the usage of thermostat. Yeah. Yeah, this is something, yeah, boiler, how it has been changed since the decades. Electric immersion heater. This is when a property has a cylinder which is heated by an electric immersion heater, hot water cylinder only. So as you can see, these are all the old type of boilers, and we do have a latest combi boiler, and then those are getting replaced with a new system as well. Yeah, as I've already referred, these is something similar to a combi boiler, wherein you get an instant. You don't need to plan something in advance. This will be connected most for our bathing purpose or something. You don't need to plan well in advance, and you get an instant hot water with this type of boilers. Whereas in the old system, you need to turn it on before 1 hour or something. So yeah, there are a lot of new advanced system, and this again has an impact on saving energy, and it has an impact on your bills as well. Yeah, again, wastewater heat recovery system. These are all something that even the UK government is sponsoring a lot of amount to get rid of this, what you see on the top at the home, because this occupies a lot of space in the loft of home, and they are currently replacing all this with the new new fancy boiler currently. This is all something, if you look at the old houses, 50 years old houses, they would have a system similar to this. There will be slight variation between India and UK, but yeah, I'm more focusing on UK based. You could relate it with the Indian system, how that works over there as well. Yeah. Yeah, again, these are all for the ratings wherein number of bath showers would be considered. Electric shower is something that it's not a mixture shower, but you just use it without turning on the boiler. That's something called as a power shower as well. Even recently, I'm saving a lot of money by changing into a power shower rather than the traditional one. So probably each one of you could consider switching to a power shower if you're not having it, yeah, currently. Yeah. These are the simple things, but it saves a lot of our money, as well as the lot of savings to the society as well. As each one of us start using less energy, we save a lot of energy for the society. Yeah, this is something that we are all excited, and we have been, hearing about this, having the solar panel at home and saving energy. I'm sure in the next 5 years of time, each one of us would have this installation at home, and we would tend to use less electricity, as uh, we would be relying mostly on solar panels like this. And it's more advantageous to be in India to have this solar panels. As I've already mentioned, 6 months period of time in abroad is more of a, it's a cold weather, and these panels wouldn't absorb any kind of energy. And for a 6 months of a summer period, summer and spring, wherein yeah, these are quite useful here as well. So those who are switching to use electric cars, and like electric cars like Tesla, BYD, and all the different makes by the different vendors, they are all installing these kind of panels at home. It saves a lot of energy at home as well as for the driving. Yeah. Any one of you here have a solar panel at home? Yes, no, maybe. Okay, so I think it's to catch up in India, right? So we most of us have solar panel here, as we are switching our diesel petrol cars to EVs, and it makes a lot of difference in terms of charging. I I believe Tesla has been launched in India, right? It, it's in Mumbai. Electric car has been launched in India, isn't it? Yes, Anshu? Electric cars has been launched in India, right? I know there are electric
Yeah,
scooters.
electric scooters are available, sir.
It's quite common, right? How about car? I've read in the recent news that Tesla has been launched. Yeah. Soon, the more vendors like Tesla, they would be launching in most of the cities and other places as well. People would tend to start using a solar panel at home because it saves a lot of money. Yeah. Okay. And energy. Energy equals money. So it's all the same. Yeah. Thanks. And yeah, wind turbine is, as we have seen in the previous slides, every property, urban terrain, and then rural terrain, all those would be rated first, and then they would analyze if this turbine is going to have any impact, and they will come up with some kind of a rating whether to install this in a particular place, what kind of benefits that the terrain is going to have due to this turbine, and then they'll take a decision where is the best place to install this. As you can see, this is something that is installed on top of a building, wherein, yeah, wind turbines, we all know about it, are used to generate electricity from wind energy. And I've seen most of the Vestas wind turbine in Tamil Nadu. So yeah, most of you would have seen while traveling as well. Yeah. So following data is required if wind turbine is present, height and yeah, rotor diameter. And if any property is renting out for a wind turbine, they get very decent, yeah, profit as well. So system defaults are 2 meter height and 2 meter rotor diameter. Defaults can be overwritten with documentary evidences. Please move on. Yeah, energy efficiency at work overview. So far, we have discussed more about the household and how we are going to, save a lot of energy by taking a. It's a simple care. To summarize in short, using thermostats to control all the boilers, air conditioner, everything, and then making sure that we keep all our things turned off during night time, and all these kind of, ensuring windows, doors, not to lose any kind of energy. And then based on the buildings, how we are going to take enough measures and handling all those. So far we have discussed all that, and I'm sure each one of you would be taking a slight measure on how to control this energy as well. And now, coming back to the topic energy efficiency at work overview, energy usage in offices and work places, importance of reducing operational energy waste. We would have seen a lot of folks, turning their things on, leaving their system turned on for a long time, even when they are away from desk. All these kind of small measures, it's a lot to the contribution. And those kind of measures needs to be taken by each individual. And yeah, importance of reducing operational energy waste is something we would always not expect admin team to take care of that. Each one of us owns the responsibilities, and it's much similar to your university as well. I'm sure. I'm sure. For example, if you're all system related, there will be a lot of labs wherein this can be controlled. We should own the responsibility. Yeah. Yeah, again, at work, there are different strategies. Use motion sensors and automated lighting systems. This is something for a house. Also, we do have a automated lighting system. It's a bit of an expensive thing, but for a work place, we could consider using it because the usage is more there, and we could have those systems in place there and encourage remote working to reduce commuting emissions. Yeah, I believe this has been happening since COVID. Almost for the past 5 years, we all have been, thoroughly, following this kind of a practice. It's slightly changing now. We used to work all 5 days from home. So, and it was one day was brought in, and then 2 days, 3 days. Now that from 2026 January, government is advising all the companies to, have folks 4 days at work. It's become a fully hybrid model. That is again, that's contradicting to the point two here, because it says reduce commuting emissions. Obviously, we are all switching to all the electric vehicles, and we would still ensure we would reduce emissions even after going to office 4 days in a week. Yeah, that's one thing. And third thing is implement energy efficient HVAC systems. That's one thing. And again, promote a culture of energy saving among employees. Do you guys have a work from home? Does the university allow you to work from home? Anju,
Sir,
does university allow you guys to work from home?
no, sir, for teaching field, it's only a particular institution only.
Okay, need to be in institute, right? Okay, that is not applicable to universities then. Yeah, fine, thanks.
Yes, yes, sir.
Okay. It works slightly differently in UK. For any kind of a engineering or masters, students they go to university for 2 days in a week, and all other 3 days they are allowed to work somewhere, even if it's under graduation. So yeah, slightly varies, and there are a lot of remote sessions also here in UK universities, even with the universities like Oxford and Cambridge has a lot of these facilities here. Yeah, thanks. So again, comparing the UK and India, UK, yeah, obviously retrofitting old buildings, government incentives. One advantage of UK is there are a lot of incentives spent. Let's say, for example, if I want to switch my diesel car to a electric car, I get a grant. I get a grant of around five 5K for switching my car. So that's one advantage. I don't know how it works in India, and not only for the cars, even for changing the boiler to a recent heat energy system. There is a grant of 8K. When I say 8K, it's 8,000 pounds. The government pays the bill for changing the latest system. So those kind of measures are taken, initiatives are taken by the UK government. I believe even in India, you might have some kind of a grant for switching to a latest technology. So a rapid urbanization. Yeah, I've seen the growth. I've seen the growth in the cities. It's much faster than anywhere in the world. We could even say the way that is being developed. The cities are being developed in a country like India. Yeah. Need for sustainable infrastructure. Yeah. And shared goal is transitioning to renewable energy. That's the ultimate goal that we all share among. Yeah, again, green homes, grant, as I mentioned already, and its impact, energy efficient building designs in India, and yeah, we all learn lessons from successful initiatives, and in the next upcoming years, we are all going to see a big difference in terms of energy. Uh, yeah, even the field like software, they are coming up with a lot of new softwares for maintaining energy for companies like Octopus and British Cash and things like that. Call to action. Again, it's an individual responsibility that contributes to the society, and we all need to own that responsibility. So, first thing is adopt adopt energy efficient practices at home and work. We have discussed in detail, and I don't want to be repeating, but yeah, that is something we need to ensure that we practice at home and work. Support local and global policies for renewable energy. That's and educate others. Those who are elder, they may not be aware of all the latest technologies and the changes that is happening. So we might need to educate them how they can, adopt to a new technology and then save energy as well as the money. Yeah, thanks. Finally, we are here with the conclusion. Energy efficiency is a crucial tool in combating climate change. We all talk about a lot on the climate change, and this is something very crucial. We need to take a collective action, and those collective actions can make a significant global impact. Yeah, again, the earth is what we all have in common, and we should take the ownership of sharing the responsibility. Yeah, that's all we have for today. Any question and answers? I've been more focusing on the UK based rather than India. Um, yeah, it all, but the concept is same and it all applies to any region across the world. Yeah. Thanks everyone.
Dear participants, we will now open the floor for the question and answer session. Participants are requested to either ask your question directly or type them in the chat box. So we have question in our chat box.
Yeah, let me see.
So can you see that?
Oh, okay. Yeah. I see a
Sir,
question. Does
we will
adding
read, sir.
okay, so
Can
the
you see
question,
the question?
yeah, I can see a question from Rani. Rani, does adding a second main heating system increase energy efficiency, or does it primarily serve comfort and coverage purposes? Okay, yeah, good question. This is generally based on the house that we live in, and when it comes to commercial, based on again the building, how big is the building is. So when it comes to example, you have seen a mid terrace property as well as you have seen a detached houses. So this is something that would apply to a detached house wherein the space is more, the central heating would not be able to cover the entire area. uh, let's say a family of four is living in a detached house, and the first main heating system covers the living room as well as the hallway. The second main heating system might go to your the first floor of where there are multiple rooms over there. So let's say the central heating system, we have a central heating system which covers the living as well as the first floor. When you turn it on, you would tend to lose a lot of energy, and let's say you're going to stay down for most of the time. So in those cases, you can use the first main heating system, and then when you want to have the upstairs covered up, you can use the second main heating system. It depends on the luxury that we wanted to have, and depends on the house that we live in. Hope that answers. Really, it saves energy.
Any other queries? No other queries? We can continue. We can conclude.
Yeah, yeah.
Dear
Thanks
participants,
everyone. Thanks for giving me this wonderful opportunity. Yeah, thank you, Vidya Academy, as well as Praveen and all the other advisories, professors, lecturers here. Thank you all.
sir, let me take a few minutes. The participants, you have any additional question, you may email them to the resource person. We will send the mail ID of sir. Then you may send your queries to the organizing to otherwise, and we will ensure that they will reach the resource person. Then, thank you very much, sir, for that insightful and engaging session on energy and environment. Your knowledge, clarity, and depth of insight have greatly enriched our understanding. The real world examples and practical perspectives you shared have provided us with an expanded view of sustainable energy and environmental technologies. On behalf of the organizing committee, all participants, and the entire FDP team, I extend our heartfelt gratitude to Mr. Murali Krishnan Verma for taking time out of this busy schedule to join us today. Your contribution has added immense value to this program, and we are truly honored to have learned from you. Thank you once again, sir, for such a wonderful and enlightening session. Thank you, sir.
Thank you very much, ma'am, and thanks everyone for you know being very active on this call. Thank you.
Thank you, sir. Dear participants, the feedback form for the first session of today has been shared on the chat box. Kindly fill it out, record your attendance. We will have the second session on 7:30 at 7:30 p.m. Now we will have a short break. You can stay in line. Otherwise, you can rejoin at 7:30 p.m. Thank you.
Thank you all.
Thank you, sir. The participants all are requested to rejoin. Good evening, sir.
Yes, good evening. Am I audible?
Yes, sir.
Okay.
Sir, let's start out.
Yeah, Praveen sir is calling.
Okay, sir.
Praveen sir, ഞാൻ join ചെയ്തിട്ടുണ്ട്. Okay. Yes, my screen is visible, right?
Visible, sir.
Full screen, right?
Full screen.
Okay, thank you.
Okay. Dear participants, we now move on to the next session, second session of the day, and it's my pleasure to introduce our distinguished research person, Professor K.P. Surendran. Sir is a distinguished scientist and academician, renowned for his extensive contributions to the field of material science and electronic materials. Currently serving as the senior principal scientist in the electronic material group at CSIR NIST Trivandrum, and holding a professorship at the Academy of Scientific and Innovative Research. He has established himself as a leading figure in his domain. Professor Surendran's work has inclusion in the Stanford University Elsevier list of the world's top 2% most influential scientists in material science. He earned his PhD in physics 2005 with a thesis titled Investigations on Low-Loss Dielectric Material for Wireless Communication. Based on his research at NIST Trivandrum, his postdoctoral journey took him across the globe, beginning with a Century Research Associate position at the Solid State and Structural Chemistry Unit, IISc Bangalore, under Professor J. Gopalakrishnan. In 2005, he was awarded the prestigious Daiko Fellowship to work at Nagoya Institute of Technology, Japan. Between 2006 and 2008, Professor Surendran expanded his expertise as a postdoctoral researcher at the University of Aveiro, Portugal, working under Professor Paula Villario. He then served as an assistant professor at the University of Coimbra, Portugal, before moving to Germany as an Alexander von Humboldt Fellow at the Leibniz Institute for Solid State and Material Research, collaborating with the renowned scientists such as Professor Olivier Schild and Professor Ludwig Schulz. Since January 2012, Professor Surendran has been a dedicated scientist at NIST CSIR in Trivandrum, progressively advancing through roles from scientist to senior principal scientist. His research interests are broad and impactful, encompassing conductive link for printed electronics, wearable sensors, EMI shielding materials, piezoelectric transfers, low temperature co-fired ceramics, and multiferroid materials. He has been the recipient of numerous fellowships and awards, including the 2023 Solar Grand Challenge Award from DST, Government of India, with a grant of rupees 3.5 crore, the Alexander von Humboldt Fellowship in 2010, and several others from Portugal, Japan, and India. Professor Surendran has a prolific publication record with over 120 SEI industry papers, more than 50 international conference presentations, and 3 patent fields filed. He has successfully led 8 major projects funded by DST and CSIR, and currently serves as the principal investigator for 5 ongoing projects. Mentorship is a significant aspect of his career, with 12 PhD students having graduated under his guidance and presently supervising 9 students, including 6 PhDs. Professor Surendran is an active reviewer for over 25 scientific journals, including top-tier publications like Advanced Material, Nature, Communication, and ACS Chemistry of Materials. His professional affiliations include memberships in the Material Research Society of India, Indian Institute of Metals, Indian Ceramic Society, Indian Association of Microscopic Research, and the Magnetic Society of India. In addition to his research and academic pursuits, Professor Surendran has served as a visiting scientist at the University of Aveiro, Portugal from 2014 to 2017 and at Belarusian State University, means Belarus, from 2019 to 2022, further enriching his international research collaborations. Professor K.P. Surendran's career reflects a remarkable blend of scientific excellence, innovative research, and global academic engagement, making him a prominent figure in the field of material science and electronic materials. Sir, it's our privilege to have you with us today. We warmly welcome you to the session and invite you kindly take over. Sir, please.
Good afternoon. Good evening. Am I audible?
Yes, sir, clear.
Yeah, okay. First of all, it is my pleasure and privilege to be part of this ATAL, refresher course program organized by your Vidya Academy of Science and Technology. And I thank the opportunity given to me by Dr. Praveen and also your head of the department and all those who have associated with this, wonderful research refresher training program organized by you. What I'm going to talk to you about is mainly some basic, tutorial kind of a presentation, and I'm not going into the details of any of the subjects that I am going to speak about today. And I am also like you, I am a student of wonderful phenomenon happening in electronic materials, and we work a little on some aspects of electronics. So before I move, as it has been introduced, we work in an institute called National Institute for Interdisciplinary Science and Technology, NIST. And we, I think in the previous days, some of my colleagues from the same department, same institute, led the classes in this refresher course. For example, Dr. Achu Chandran, who gave you a talk yesterday or day before yesterday, I don't remember, belongs to my department, and he's a prominent scientist there. Like that, So this year we are on the final days of celebrating our 50th year of our existence, and that celebrations are almost concluded. So we are now 50. I am slightly above 50. Okay. Yes. These are some of the, as it has been kindly introduced by your teacher. These are some of the research topics that I work here in an IST. One is conductive inks and devices. Basically, it is all about electronics on plastic, or electronics on paper, or electronics on leather. In short, electronics on flexible substrate. And then we work on effects of electronics for on materials devices. So that's called materials. We develop materials to suppress the effects of electromagnetic interference caused by stray electronic and electrical circuits in a system, like in mobile phones, in laptops, in any electronic integrated chips and stuff like that. So, and also we work on an innovative electronic, materials. They are called hybrid electronics. That hybrid electronics is something that has to do with alternate electronics. For example, alternate electronics means you are all familiar with silicon electronics, because your mobile phone is having several billions of microchips. not microchips, several billions of transistors and also other components. For example, one of the latest, microprocessors uh, produced by Intel is having above 5 billion transistors. So that means that is the level of innovation happening in the field of silicon electronics. But silicon is having a certain problem, and that problem is nothing but the problem of endurance in extreme conditions. One is that silicon will fail in high temperature, silicon will fail in low temperature, silicon will fail in high pressure, silicon will fail in extremely high humidity. So in these conditions, you have to look for alternative electronic, concepts and platforms, and they are called hybrid electronics. Where hybrid electronics means, you can realize electronics on top of plastic, realize electronics on top of ceramics and stuff like that. And also we work on many aspects but some of the major topics that we are working on is multifunctional materials. For example, we are trying to combine two important material properties called ferromagnetism and ferroelectricity, and we try to find these two phenomena combined in a specific combinatory materials. They are called multiferroic materials. And these are some of the, you may not have been aware of all this, just I gave you an introduction. But today, for the sake of this talk, this will be a short talk, and I will be speaking mainly on devices, that too, biomedical sensors. That is what the title already given to you. So before I go into anything, so I am just introducing you a picture of a gentleman smiling at you, a handsome man, and I am posing a question to you as to who is he. You can guess it. Some of you may be good enough to guess this man, from your basic knowledge of, browsing the internet, and also from reading through some of the most popular science books. Oh, sorry. So this gentleman is a professor in Cornell University, and he is no more now. But he is considered to be one of the greatest popular science writers and popular science, popular scientist. Briefly, if I describe him briefly, I don't know how. Some problem. Okay, and he during 1980s, by the end of 1980s, he produced one of the most popular, TV shows, and that TV shows were called Cosmos. I don't know. Still, if you browse in internet, so you will get the episodes of that. 12 episodes are there. This is considered to be the most hit TV shows ever in terms of popular science, because it talks about everything. And later, this has been made into a book, and that book is called, famous book, it is called Cosmos. Okay. So in one of the chapters of that book, he was describing what a book is. A book is derived from trees made of flexible parts derived from trees, inscribed in them tiny, funny, dark squiggles. And one glance of a book, you are into the mind of another person, maybe somebody dead for thousands of years ago. That means book break the shackles of time. If I were to paraphrase Carl Sagan's famous quote, books break the shackles of time, I would say printed books break the shackles of time. I will say why. Because you can just imagine, you have seen a photograph like this, not a photograph, it's a painting. you can see that one scientist is describing his invention to his apprentice juniors. And by any chance, do you come across this kind of an image? Sometimes you must have seen this image. And this gentleman, I will give more clues about this gentleman who is holding that paper. His name, he is hailing from a city in Germany, which is called Mainz. And by profession, he is a blacksmith, because his idea is to make, and his profession is to make polished metallic materials and polish them to mirror finish so that they work like mirrors. That means his job is to make metallic mirrors. One fine morning, he is struck with an idea that, why can't I make these kind of metallic mirrors for something miraculous? He used these metallic mirrors and he attached some metal letters made in the form of metal. Metals made in the form of letters, and he attached them to these metallic blocks, and he used them in his wooden device. And he found that using this metallic device, he could print each letter. So what he did is that he printed each and every letters of German alphabet, and using that technique, he printed the most influential book of that time. That is nothing but Bible, the Holy Bible, and that book is still available in that university. And this gentleman's name, if I say his name, you will get to know how simple this question is. His name is Johannes Gutenberg. Johannes Gutenberg's invention is path-breaking, because until that time, there was no knowledge about reproducible inscribing of letters. Until then, people were using, people were rewriting holy information by writing on calfskin or maybe sheepskin. So you have to kill several, calves for writing a full testament of the Holy Bible. So that was the situation. So that means after some time, they found that this kind of printing can save the life of cattle. And more importantly, until that time, the knowledge was confined to the rich and the influential. So when the printing technique became popular, the price of books, or the printed books, even the Bible, became so small, so low, that it could become available and affordable to the poor and the marginalized. So that means knowledge is not now a privileged item, but knowledge is now spreading far and wide across the globe to the vast horizon. So, the reverberations and the consequence of this kind of a revolution is that it is nothing but, for example, the cultural awakening happened in Europe, called a Renaissance, the Protestant Reformation, and the most important thing is the scientific revolution. The scientific revolution created everything that I and you see in front of you: the electricity, the cement, the steel, iron, all these kind of things. All the things, telecommunication, whatever you say, it is actually an outcome of the scientific revolution. It all started from the time of Galileo Galilei, and it ended. Maybe you can say that it survived until the Second World War. Okay, so what I am going to do in my laboratory is that I am now combining the merits of printing into electronics. So that means I am marrying two competing techniques: printing and electronics. So the techniques that we use in our laboratory, in a way, we can abbreviate. In short, we can call it a printed electronics or flexible electronics. But believe me, I am not an expert in electronics. My knowledge of electronics is even worse than many of you. Huh? But we have some knowledge in materials, and we have some understanding of the current market demand. So we are generating and creating materials and solutions and technologies that is useful for the growing demand in the field of electronics. Okay, so that's what that in 1940s. Even before that, the electricity was the alternating current was made possible by Nikola Tesla. The telecommunication device, the telephone, was actually invented in the early years of the last century by Alexander Graham Bell, and he made a lot of fortune out of that, and he made a big laboratory in California, and that laboratory is called Bell Labs. You heard about Bell Labs, right? And the all important revolutions in the field of modern science happened or originated from that laboratory. In 1948 December, three scientists. One is William Shockley, Bardeen, and Breton. These three, actually, it is William Shockley gave the important idea that he was trying to make close electronic contact around the junction of P and N regions in a piece of germanium. And he gave the idea to his juniors. They are Bardeen and Breton, and he went for vacation. And then Bardeen and Breton made a wonderful device, because they found that if you make too closely spaced electrodes across the junction of a P type and an N type, N behaving and P behaving, portion of a PN junction, the voltage in one section can control the current in the other section. That means, in a way, you can control the one peculiarity of electronic signals passing through that piece of semiconductor. So that means they gave birth of the first transistor, and the Bell Labs made a wonderful announcement in 1948 that they made a first transistor. After that, then a lot of startups sprouted in different regions of that part of Mountain Bay regions of California, San Francisco. And then one of the startups is Texas Instruments. So there, one gentleman with the name Jack Kilby, and independently in another institute, which is called Intel, another firm which is called Intel, they have made success in integrating several electronic components like a transistor, a few transistors, and a few resistors and capacitors together into a small die, and that we call it as the first integrated. These are all about the history and evolution of electronics. But as of now, you can see that now we are Core i9. This is the kind of electronic density in the modern electronic chips that is happening. So that means it is very, very in electronics, the memory requirement is very huge, but the space available is very small. So a lot of challenges. If you are given me time, I would have talked for hours about the challenges in electronics. So this is in parallel to that. In the new millennium, what happened is that in parallel to the huge revolutions in electronics, another technology came up, and that technology is the technology of touch. And that kind of a revolution made possible by the extensive research happened in some of the private industries, including Apple. Okay, and in 2007, Apple came with the idea of touch screen. Okay, touch screen concept was there before, but everything integrated into a mobile phone was introduced by Steve Jobs' company, Apple, in 2007. And thereafter, the evolution of flexible electronics happened after that. Now, as of now, you can see that we have a lot of electronics but the electronics is now coming more and more close to our body. Okay, electronics is now going to be flexible, and electronics is now going to be wearable, because these days the sensors that I and you are talking about is going to be attachable to your skin, or even it can be realized on top of your skin as a tattoo. Okay, so that means things are coming to that level of innovation. So that means challenges are huge. Okay, so that means the future of electronics is flexible and wearable. So that means wearable technologies, that any technology that you are going to wear in your wearables, like your shirt, your hat, your belt, your jacket, your shoe, or whatever. So that kind of a technology is wearable. But you know that this wearable technology is very important, because these days we are all talking about Internet of Things. Internet of Things is that you are actually creating an array of sensors, and these sensors are intelligently responding to their immediate surrounding, and also recommending what is to be done to a set of controlling units where the data is being stored in internet in huge amounts. So the present time most valuable thing is data. So that means when you are talking about many sensors being integrated together for want of technologies like integrated Internet of Things, then you need to have a lot of data to be handled. And some of the sensors that I'm going to talk about is the sensors that can be wearable. So wearable sensors. So wearable technology can be worn as an accessory, embedded in clothing, implanted in body, or tattooed on the skin, as I have mentioned in the beginning. But you can see that I will ask you a question as to what is the first wearable technology that man has ever invented. It is not fabrics and all. They are not wearable technologies. They are just wearable. The earliest technology that mankind used was actually, it is a pair of goggles. You know, Alex, it's Salvino di Amante. He is an Italian, glass maker. He made a pair of glasses attached to a gadget, and he weared that for reading and magnifying and helping reading and magnifying letters and all that. Later, Roger Bacon is a well-known figure in medieval Europe, because he's a polymath, and he has been traveling all across. He's from Oxford, but he was traveling all across Europe, and he popularized this kind of new innovation. He put hands in almost every aspect of knowledge at that time, but he introduced this kind of new technology to the most powerful man of that time. He is none other than the Pope. Okay, and then the second wearable technology that man ever invented is nothing but a portable watch. Okay, so this is the first portable, but this innovation happened not in UK, or not neither in Italy, but in Nuremberg, a place in current Germany. Okay, and the gentleman's name is Peter Heinlein. And then there are many other, like a wearable calculator, like that. There are many wearable technologies emerged over the period of time. But wearable technologies can be, that it is going to have huge market. So there are billions of dollars. All wearable technologies are going. So that means any wearable technology can be smart glass, smart watch, shirt, like that. Any wearable technology that so in those wearable technology, what I'm going to speak about is a wearable sensor. Generally, a sensor is that, a sensor is something that sensing the external stimulus, like a temperature, a pressure, or heat, or whatever. So that is what a sensor. So that is what basically a sensor is. Any sensor you take, it will have invariably four parts. It's basically a sensing element that is actually communicating with the external element, and a transducer that converts the kind of information that is being read from the sensing element into a readable electrical format, but the signals will be very weak. So you have to amplify. So a signal conditioning circuit should be there, and an output indicator in the form of a display or something is also there. Wearable sensor is, as I have said, it is something weird. I mean, something not weird, something worn on your body. So a biosensor means a device that combines the transducer with biologically sensitive and selective components. So that means a biological sensor or a biosensor is sensing anything that is in your body, like your heartbeat, your your sweat, your blood, your whatever, your disease, or anything that you have to worry about or you have to be happy about, in your body. So that is going to be sensed by a sensor, and this is called biosensor. So we have been working on several kinds of sensors, but I'm just going to talk about a few sensors that we have recently developed. One is Hall effect sensor. You know that what is Hall effect? When current pass through a conductor which is kept in a magnetic field, and the direction of magnetic field is perpendicular to the direction of flow of current, then a voltage is generated in the third direction. That is what a Hall effect means. We have made a Hall effect sensor, and that Hall effect sensor is useful for many applications, and one of the applications is in automotive, where you have ABS, anti-lock braking system, where this kind of sensors will give you exactly the position of the steering wheel or the tire or any part that is moving, because the position of a moving part you cannot sense by touching it, because it is moving. So by sensing its position is a tricky way. So here this kind of sensors are used, and we have a lot of requirements at home also. These days we are using BLDC fans, and for brushless fans and motors, you need this kind of sensors like that, the food emitters, ignition system, fluid flow sensors are there. For example, a blood flow meter that you have in your hospital, or even the screen flipping system of your mobile phone. All these things are working with the help of Hall effect sensors. And we have made a Hall effect sensor, and that Hall effect sensor, you can see that it's having very high sensitivity, and the Hall coefficient is to the tune of very close to what is being reported. So this work is a bit old. This is one of our first work on wearable sensors. After that, we worked on wearable antenna. Since it is not a sensor, we are the first to make a wearable, a fabric wearable antenna on a jacket. And when we published that, it was the first of its kind, and the news was being published in the Hindu, Malayalam Manorama, Madhurabhumi, all these newspapers. So that means it was. I mean, I'm not going to talk about that, but what I'm going to tell you is that we have other aspects as well. Then this is the paper where we are dealing with this wearable Hall effect sensor. The second sensor that I'm going to speak about is thermal sensor. Thermal sensor means anything that senses temperature. But you can see that thermal sensor, you know what is a thermal sensor. Anything sensing temperature means a thermometer is a very good thermal sensor. But thermometer can sense only the temperature of a point, not, for example, you have different temperatures around across your forehead. Then the temperature profile of that part of your body cannot be given by a thermometer. So for that, you have to make a wearable, thermometer or a wearable thermal sensing system that we have been working for some time. We have made some materials through which you can make a contour of temperature sensing devices being arranged. So that kind of temperature sensing devices we have made, and these sensors are very useful because for any thermal thermotherapy systems and all that, you have to exactly know what is the temperature requirement for example, recently we have been working on a system which is actually, it is not for our country, of course, for winter countries where you need heated car seats. But you know that heated car seats, when do you need to trigger the heating? So for that, you have to accurately measure the temperature of the car seat in different portions of the car seat. You know that in winter countries like in Germany, in Scandinavian countries and all that, the entire car as well as the interior of the car is completely cold, frozen. So the moment you step into the car, you will feel like you are going to die. That kind of cool, that kind of freezing situation is there inside the car also. So that means this kind of car seat, I mean, this work currently we are doing as part of another project, and I'm not going to give the details, but this kind of sensors are highly useful for sensing the temperature around a particular area. That means a contour, temperature contour mapping can be done using an array of temperature sensors. And this is the earlier result in that, even more advanced results we have, I'm not going to elaborate. And then another sensor that I'm going to talk about is the humidity sensor. Humidity sensor is something that sense humidity. For example, when I'm speaking, the kind of air that is coming from my mouth is humid, more humid. That is why in winter countries, when you are speaking, you feel like you are smoking, because the atmosphere, the moisture in the atmosphere condenses on the hot, air particles that coming out of your mouth. That is why it's like a smoke is coming out of your mouth. Anyway, so this kind of humidity sensors, but we are having a different requirement. What we were required by an industry is that, this kind of sensors are used for, automated irrigation system. You know what is automated irrigation systems? In previous speaker was very elaborately talking about smart homes, so automated irrigation systems are like they are sensors are being placed in the soil in different parts of a garden, for example, and at certain time when the sun is very hot and you need water to be given to the plants and the grass or whatever and the vegetation is there, then the sensors will tell, because they are in touch with the soil. Sensors will give a signal to the motor triggering to trigger the pumping. So but the problem is that since sensors are inside the soil, the sensors are getting corroded. You know what is corrosion? Corrosion means it's kind of turumbikia. So that is what corrosion. So that problem has been addressed successfully. The company, the industry asked us to develop a sensor that is not touching the air, touching the ground. So that was a big challenge. We made a sensor that is not touching the ground. We made a sensor. I'm sorry, my keyboard is having some anomalous response. So that is why it so happened. Sorry. So what happens is that this kind of sensors we made certain sensors, and these sensors are made from gold. So gold is having a peculiar mechanism. It's called Grotthus mechanism, where when gold is in contact with atmospheric air, water molecules are getting condensed on top of that, and that process is creating some kind of electron exchange between gold surface and the water molecule. Anything that involves an electron exchange means there is a voltage difference or a current flow is happening there, and that is actually being correctly noted by a device. We have made a device, and that device is actually creating touchless or touch-free moisture sensors. So this kind of touch-free moisture sensors we have made, it could sense very accurately, because the order of resistance change is fifth order. So that means For very small change in humidity, the kind of measurable data is huge. So this kind of sensors are very accurate and very sensitive. So we could sense using this, and we didn't stop there. We made an automatic irrigation system, and even before that, we made a, a breath analyzer also. And due to the paucity of time, I'm not going to elaborate that. So, but this kind of automatic, irrigation systems we have made, where we have placed these sensors in different areas, in a small different areas of a field, and when the time required, this sensor is giving an alarm, giving an information that the atmosphere is very dry, please start pumping. Then that we have programmed a microprocessor using an Arduino, and then that pumping is being triggered. So this means if this kind of sensors are being arranged in different parts of an irrigation system, then you can sit at home, but the pumping will do as and when required when there is a scarcity of water. So this is what we have. I mean, this work has been sometimes back. We have published this work in ACS, American Chemical Society, Applied Nanomaterials. So another sensor is called self-powered tactile sensor. Tactile sensor means it is a force sensor basically, but we have a tradition of and legacy of working on piezoelectric materials. You know what is piezoelectric material is? A piezoelectric material means a material when it is being used for a specific application, like you want to generate electricity out of force, then this kind of piezoelectric materials are being used. But currently, the materials that are used for this kind of piezoelectric applications are lead-based materials, like lead zirconium titanate, lead magnesium niobate lead titanate, and also like that, the lead zinc type tantalate, like that. There are many other materials which are having a toxic lead component there. So we don't want to contaminate our world with the lead. So we thought that we will make it work on lead-free material. And some of the materials we made are potassium sodium niobate, and also one polymer which is called polyvinylidene difluoride. So that kind of materials we made, and we electrode spun this kind of composite material in high electric field, and then we made fibers. Using fibers, we made fiber mat, and then we have made a piezoelectric nano generator, and this piezoelectric nano generator can be able to work as a force sensor with very high sensitivity for extremely low input forces. That means even for a feather touch, you can see that, even you can read this paper, even for a feather touch, our sensor is able to good enough to detect even extremely small pressures. So this kind of the sensitivity curve is being shown in this image. So you can see that, so this kind of extremely small pressure, it can be sensed with sufficiently high voltage. So this kind of sensors also we have made. So this is and we didn't stop there. We have used this technique for acoustic sensing, ultrasound sensing, and all that. And also one of the techniques that currently we are into the development is called artificial electronic skin. Electronic skin means, a skin can, once you touch on the surface of your skin, you can see that when you are touching it, you know that the skin will sense exactly the sensation at that point. That means it is the sensor in that particular coordinated point is actually triggering the information, and that information is being processed by our very efficient microprocessor in our brain. So this kind of very efficient electronic array of tandem array of sensors being on flexible platforms and elastomeric platforms were being made, and for static as well as dynamic forces. That when a dynamic force is being, for example, a dynamic force means you are tapping on it, you are putting an impulse on your skin, or you are putting a static weight on your skin. So this kind of static and dynamic forces as well as temperature, all these things can be integrated in tandem way, And that kind of sensors we have worked as part of another project, and that is called electronics in the paucity of time. I'm not going to. So that means this kind of tactile sensors or force sensors we have a tradition of working with. And then the next sensor I'm going to talk about is called proximity sensor. You know proximity sensor better than me. Anything that comes close to you, a proximity sensor is actually giving you an alert. So in your college also, you must be seeing that when you are entering into a room, the door is opening and closing and all that. So that kind of sensors. But this year we have used another interesting technique because we have a tradition of working on microwave material. As I have said, as it has been said in the beginning, that we have a lot of facilities for microwave measurement and testing. So that means we use a technique using a radio frequency identification tag or RFID, and for that we made an RFID which is printed. So since we have the knowledge of printing, we made RFIDs using printed electronics. So, but for printing, what do you print? You are printing the electrodes of an RFID, but the electrodes of an RFID when you're making, so you say these kind of electrodes are being made with the help of silver nanowire. But when you are making this kind of silver nanowire, as it is being shown in this image, so silver nanowire, when they are making, so the silver nanowire will have a sheath of insulating polymer, which is called PVP, polyvinyl. It's basically a pyrrole-based, pyrrolidine-based polymer. So this polymer has to be selectively used. It's a hazardous job and it is a very, very cumbersome job. You have to do it very carefully. But we have succeeded in doing that, and we have made an ink using silver nanowire, and that ink was used for making the RFID, antenna. And using that RFID antenna, we have, due to the positive time, I'm not elaborating them. We have made an RFID sensor, an RFID integrated proximity sensor using that. So these sensors are limited by the capacity of the sensor reading, RFID reader. If it is having an active RFID, then your read range will be up to some 20, 30 meters. But if it is for a passive one, then your read range will be maximum 1.6, 1.8 maximum. So what we have made is a passive RFID. Active RFID is very expensive. But you can see that all these devices are wearable. You can wear them in the form of an armband or something like that. Now I am going to the heart of the topic, which is biomedical sensor. But you know that in the aftermath of COVID, this device became very popular. You remember, this is actually a pulse sensor, or it's an oxygen, saturated oxygen analyzer or something like that you can call. So using this, the oxygen level as well as the pulse level could be. And during COVID, this was very necessary because sometimes your oxygen level will go below critical levels, and that will risk your life. So using pulse, usual this kind of sensors are working by the principle, are optical sensors. They are work by the principle of shining a green light using a green light emitting source on the finger, and your finger is partly translucent, and the amount of light reflected with the photo sensor that is being kept on the other side. So this kind of sensors are very very popular at that time. And the oxygenated hemoglobin in your blood has a property of absorbing green light. The redder the blood, the greater the absorption of green light. With each heartbeat, the blood is pumped through your finger, causing a change in the amount of the reflected light, and which in turn produces a waveform. And that waveform is in the form of a kind of a sinusoidally varying waveform, and that sinusoidally varying waveform we wanted to recreate. But we know that we don't have money for this kind of very high sophisticated sensors to be made in the lab. We are poor people, so we wanted to make them using the simplest way. So how did we make? We make them using a simple technique called piezoresistance. Piezoresistance means the moment you apply a force on a sensor, on a material, its resistance changes. So that means if you apply a force, if its voltage changes, we call it as piezoelectric. If the resistance is changing, it is called as piezoresistive. So this kind of sensors are very popular in electronics, but it is very difficult to fabricate because their accuracy level is very, very critical. But we have succeeded in making this kind of material. But what we have done is that we don't want to make a expensive material for this purpose. We started with some of the well-known conductive materials, and they are called carbon nanotube. You know that carbon nanotube is actually carbon graphene wrapped in the form of a tube. But single-walled carbon nanotubes are very expensive, so we resorted to multi-walled carbon nanotubes. We made multi-walled carbon nanotubes, and then multi-walled carbon nanotubes we made the sensor, but they are not having the sufficient electrical conductivity. So what we have done is that because the inter-tube resistance of multi-walled carbon nanotube is very high, and they are having very, very big effect of bundling. So we want to spend a lot of hours for debundling them. So what we have done is that we have decorated, silver nanoparticles on top of this kind of multi-walled carbon nanotube, and then we have made this material as a standard material for fabricating the conductive ink for printing your antenna. Okay, the antenna was printed, not the sensor, not for printing the antenna, the sensor. So we printed the sensor. So this is basically the sensing element. But there is a problem with this. Because the moment we started, working on this kind of an antenna, we wanted to make the strain to be measured. For that, the printing has to be done on an elastomer, like a PVDF or something like that. But unfortunately, that on top of an elastomer printing is extremely difficult. So what we have done is that we have resorted to a technique which is called transfer printing. So this is what transfer printing means. That's a bit complicated technique. Using that, so it's the peel of transfer printing. The strain sensor, we made the simplest strain sensor, believe me. But this kind of a strain sensor is being finally realized on an elastomer, and that elastomeric sensor, when you are bending it, it is showing differential electrical conductivity. That means when it is bent a little, it is showing a drop in resistance. When it is bending little more, sorry, not drop in resistance, increase in resistance. When it is bending little more, it's showing an further increase in resistance. When it is bending further angle, it is showing higher bending, higher electrical resistance fault. So that means, and when it is bending in the other side, in the opposite direction, so instead of fall in resistance, an increase in instead of fall in conductivity, an increase in conductivity is observed, because since it is more and more electrical conductive elements are in contact. So that is how. So that means we have to find a parameter which is called gauge factor. If you are engineering student, you know what is a gauge factor is. I'm not going to elaborate that. It is actually a figure of merit of a basic sensing element is. And what we have done is that we have bended, we have attached this sensor to a gloves, and then we have bended for different bending angles, and the delta R by R value, which is nothing but the gauge factor, has been identified, and different bending angles. And what we have done is that we have noted these, we have fed these values into a microprocessor, and that microprocessor is connected to a servo motor, which is actually connected to a robotic arm. What interesting result that we have got is that, for example, this is a video that will give you an answer. So here what happens is that, you are bending your arms in different angles. You can see that, surprisingly, your robotic arm, that this is a robotic arm, which is not the best robotic arm that you are seeing in market. Why? Because we are children of leather gods. We don't have money, so what we have collected is do it yourself DIY robotic arm made from YouTube. Sorry, made from Amazon. But you can see that it is exactly responding to the variations of your actual hand movement. So that means this is actually one of the most accurate, this kind of piezoresistive sensors made on a glove. And so the interesting part is that this technique we have used for different applications. One is that a, 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 a breath analyzer. This sensor is attached to a stopgap face mask, and that face mask is being 3D printed. And then we have asked the volunteer to walk fastly, run, walk slowly, and all that. During all these operations, your breathing speed will be different. Then we made this sensor to be attached to a bandage, a kind of special bandage, which is and it is being pasted over your artery, your radial artery, and you can see that the kind of accurate reading of its pulse, our pulse, using the during the systolic and diastolic, contraction and expansion of your heart, that is being reflected on the variation by the variation of the of pressure on your artery. So that is actually accurately being recorded. So that means the sensor that we have made using very cheap method is very accurately reproducing the functioning of your heart, because there is something called augmentation index. Augmentation index can be calculated from your systolic and diastolic pressure. The formula is given here, and for a healthy person, augmentation index range should be something around 40 to 50. And we got we made these parameters to be measured across a large volume of volunteers. We found that the kind of values that we are getting is very accurate. And these results, some interesting results of these are published in this paper, and other results are being waiting for getting a patent. Now I am coming to the last part of my talk, and this is nothing but a biosensor, which is actually useful for mankind. Of course, all sensors are useful for mankind, but that we, especially people living in Kerala, are having a big worry of lifestyle diseases. One of the popular lifestyle disease is diabetes. You know that diabetes. What is diabetes? Your blood glucose level is above a critical value, then you are diabetic. And in Kerala, if 10% is the 8 to 10% is the national average, we have something around 20% of the Kerala population is either pre-diabetic or diabetic. So that means we need, of course, this is actually an after effect of a developed society. Of course, we can call somehow in that direction. So where you have a lot of lifestyle diseases are possible. So, and this kind of lifestyle diseases, one of the important problem is diabetes. So you have to accurately measure the diabetic glucose level of blood. But you know that a sensor that is sensing this kind of thing is called an electrochemical sensor. But most of the electrochemical sensors that is available in market are having a problem, that they are pricking on the skin and causing you several pain and blood and all that. That blood is being taken into the analyzer, and that is being given using a potentiostat and all that. So that technique we don't want to use. We decided we will not do this testing in a painful way. So what we are trying to do is that we wanted to explore other possibilities. But that blood is one very easily detectable, easily glucose detectable analyte. But other than blood, you have other analytes in the body. Urine is one, and then your saliva is another one, Sweat is another one like that. There are many analytes and many other secretions from your body. So we thought that why don't we work with the sweat? Big challenge, because sweat is, most of these are kind of expelling out from your body. So that means it is full of waste, a lot of unwanted salts, unwanted acids, and some portion of the glucose. So that means you have a lot of adulterant components are there. So that adulterant components we have to explore, we have to eliminate. So that is the biggest challenge. And so the challenge given to us is that in a glucose sensor you expect. And so we took up this challenge. We thought that we will make an electrochemical sensor, but the most popular technique is called cyclic voltammetry. We don't, where a potential is being applied to the working electrode. In cyclic voltammetric sensors, there are three electrodes: working electrode, reference electrode, and counter electrode, where the glassy carbon electrode is the working electrode, reference electrode is silver and silver chloride electrode, and counter electrode is a platinum or any high conducting material, gold and all that. So we thought that we will not work on the cyclic voltammetry. We will not work on glassy carbon electrode also. We wanted to make our own electrode, that is a printed electrode. So we wanted a printed electrode that we have made, where we resorted to a technique which is called a chronoamperometry. Chronoamperometry means we are feeding, we are getting the accurate voltage requirement from the cyclic voltammetry, and then we are feeding a square wave into the system, into that analyte, into that sensor, and then the potential of the working electrode is fixed, and the resulting current is measured as a function of time. One more technique is also that also we work with, is called differential pulse voltammetry, where the applied potential is swept in a stepwise manner, and each of these potential steps in a small differential potential pulse is applied to the working electrode. So these techniques are equally good, but we have to decide which one we wanted. So what we have done is that our blood is having, our sweat is having a lot of unwanted things like sodium chloride, ammonium chloride, acetic acid, lactic acid, ascorbic acid, uric acid, and whatever are going to damage, going to give you wrong information about sensing glucose. So that means we have to alleviate the effect of these sensors. So that is what we critically modified the working electrode using multi-watt carbon nanotube. Then for different oxidation state, we used a ferrite called Fe3O4, then PE.PS was used, then Prussian blue was used. Like that, we have used many components in the working electrode, and it is actually a concoction of different components. And using these components, finally, what is that we have developed an enzymatic glucose sensor, and that glucose sensor is actually giving you very high sensitivity of and selectivity of artificial glucose that we have developed. But that artificial glucose is something that that people wanted. People don't want, because artificial glucose, artificial sweat is not something actual sweat, So, but for getting and studying actual sweat, you need something called sensitivity and selectivity, or sensitivity clearance. The sensitivity clearance or ethical clearance. And this ethical clearance is actually a very laborious and long procedure, where even though the volunteer is known to you, it has to be screened through a committee, and the committee has to decide whether you are getting paid, your anonymity is being safeguarded, like that. There are many parameters that you have to follow to make this ethical clearance before a committee, and that we have done. And then initially we have done with artificial sweat, and you can see that using this is the kind of sweat sensor that we have made, This is a photograph, and the other is the scanning electron micrograph. And you can see that maybe for other things, for the simple understanding, you can see this figure D. In this figure D, you can see that when glucose is added, it shows an increase in current. But when acetic acid, ascorbic acid, lactic acid, all other, and sodium chloride, ammonium chloride, all these things, when they are added, there is no change. Then again, glucose is added, it is increasing. Okay, that means it is having very high sensitivity. And then when it is bended, because you are going to wear it, right? You are going to wear it on an armband. So when it is bended for different angles, you can see that it is not having not much effect. Like that, then we have done differential, different devices we have made, and all these devices are showing reproducible results. And so that means all the qualification tests needed for a sensor we have done. Finally, we have done with actual sweat, because we have got the sensitivity clear. And using actual sweat also, we got very, very highly reproducible results. You can see that, when the current is increasing with the increasing concentration of, current is increasing linearly with increasing concentration of your glucose in blood. Because blood is being diluted, glucose in sweat. Sweat is being diluted and is being periodically spiked with the different volumes of your glucose. So that is how it is being done. So this work, and this sensor is very accurate and very sensitive, as well as it is very, very selective, because it is showing no response with contaminant or adulterant, but it is showing response only with glucose. So that means this kind of sensors can be worn on an armband, and your sense, if using a potentiostat, your data can be decoded, and that can be read using an RFID, because we have knowledge about all these things, RFID, and that RFID will send the information down to a base station where a doctor is sitting. So while you are working out, your body's actual glucose level variation can be correctly and accurately identified. So that was the idea, and that is what we have got. So even this is blood glucose is one thing, and then adrenaline is the one that we have made, ascorbic acid, and then many other vitamins, and acetylcholine is something. There are many blood-based analytes we have periodically made sensors, and due to the paucity of time, I am not elaborating them. So that means this kind of biosensors, development of biosensors is one of our close to heart research area. And currently we are working with diabetic wound healing using this kind of biosensors. It's a very challenging problem, because diabetic wounds are having incurable nature. So using our sensor, we will give you whether the wound is our sensor, our bandage, which is integrated with the sensor, will give you correct information whether a wound is getting healed, and also we are actually integrating some other techniques that will help the curing process, the recuperating process. So that is a big challenge, and the challenge is being done with one of our students. So that kind of challenging problems currently we are taking, and I'm giving you only a tip of the iceberg result of one research direction that our research group is working on. So this is actually, in a nutshell, you can see that the very low limit of detection for this, and it's having very low price. Even the current sweat, not sweat, blood strip available in the market is minimum 50 rupees, and we got something 1/4 of that, 10 to 15 per strip only. So that means our sensor is cost effective, as well as it is very easy to fabricate, and it is very selective and sensitive. Well, in a nutshell, these are some of the sensors that we have just seen from the surface, nothing seriously gone deep into. But these are some of the sensors that we have just now seen. And electronic skin, it needs 1 hour for you to teach. So I'm not, and it is a collaborative work. Many of these works are collaborative work with our group and my colleagues group. And so that is why I wanted to uh, acknowledge my collaborators as well. But my funding agencies, for example, we have been generously funded, supported by our mother institute, CSIR, and ISRO. ISRO is supporting us in continue to support us using a response program. And then SERB, now it is Anusandan Research Foundation. They are supporting us. Then Advanced Manufacturing Technology, they have supported us 2 projects. And then Solar Grand Challenge, we were doing. And these are all financial part, but my group, this is a group sometimes back. This is not the updated group, and many of them have completed. But what I have shown is the results of years. So, but they are all wonderful researchers, and they are very hardworking and intelligent, much more intelligent than me. Okay, and I should not forget my very close collaborator who gave you a talk last day, Dr. Achu Chandran, because Achu Chandran is actually helping me in solving all the problems in electronics. I am not an expert in electronics. I'm working on material side and material development, and then we work in collaboration in many research fields. So that is how my research. Most of them have gone. Some new students joined, and this is the current status. But even in this group, also many have gone. New students joined. I don't have the latest photograph, but my group became more like a men's hostel. You can see that. So, and so this is all about my research. Thank you. If you have questions, I will try to answer if I know the answer. Thank you. Hello.
Thank you, sir.
Yes.
Thank you, sir.
Yes. Yes, if anybody has.
We will now begin the question and answer session. Participants. Yes, sir. Participants may raise your question verbally or type them in the chat box. So we have received some questions in the chat box. Let us start with sir.
Yeah, you can tell me, because at the moment somehow I am not able to see the chat box. You can
Okay, I will
read them one by one.
What are the advantages of?
Yes. Yes, you can.
Sir,
Okay, sir. Okay. Temperature environments. Sir, can you hear me?
You please repeat. Somehow in between the connection gone. Hello.
Okay, sir. Once again, what are the challenges of using piezoelectric sensors in high temperature environments?
Okay. Yeah, piezoelectric sensors, wearable piezoelectric sensors, it is almost temperature limited, because wearable means it should be worn on the body. So that means it should contain a ceramic plus a polymer. But you know that polymer means it is a low melting material. So ceramics can go to very high temperature. Like for example, if you are using a wearable sensor made of a ceramic material up to maybe 100 and 1000 and 200, up to that level, it is okay. For example, PZT and barium titanate, all these materials are high temperature stable materials. But when you are making a wearable piezoelectric sensor, you know that it should be composited with a polymer. So that means the polymer will not be stable at high temperature. So a high temperature piezoelectric wearable sensor is always limited by the melting or the temperature, deformation of the polymer. So that means maximum you can go, if you are using CVDF, maximum you can go up is maybe 200 degrees, beyond which the polymer will degrade in a big way. But if you are using a thin film based solid state sensor, even at high temperature, you can go like up to 1000 degree, you can go. But in 1000 degree, your electrodes may not stay, and some of the electronic components also will degenerate, but the material will not get damaged. That is my point. Okay, then. Yes.
One more question we have received from Chain Biswasa. Normally, a person sweets heavy in summer season that affect the reading of glucose level using sweet sensor. Once more question, once more you need.
Yeah, I need, somehow, I don't know, all of a sudden my connection is giving me some disturbance. Yeah, you can repeat the question, please, if you don't mind.
Okay, sir. Okay, sir. Normally, a person sweats heavy in summer season and least during winter season. Will that affect the reading of glucose level using sweat sensor?
Yeah, interesting question. This we have come across many times. For example, not only in summer and winter, during different times of a day, if you measure your glucose level, that is why when you are going for glucose test, the doctor will prescribe you, please come with fasting, right? Because after eating within 1 hour, all the glucose will come to your bloodstream. So that will give a very wrong, wrong indication of the glucose level. And in summer, definitely your sweat production will be much more. Sweat production will be much more than in winter. So that sweat, if you are doing that sweat is having definitely a different level of glucose than in winter. Over the entire period of year, we did not test, but we have tested in different periods of time. We found that it is having a problem. It is not a problem of our sensor, but it is a problem of our body. Body is giving different values of glucose in different times of an year and different times of a day also. So that kind of problem is there. That's an interesting question. We have even with several volunteers after meals, we tested the glucose level of all my students. They are all came ready as volunteers. We found that some of the boys are having slightly upper level of glucose than the girls. I mean, there may be exceptions, but on an average, I could see that maybe because of their metabolic and biological activities, the girls shown very normal composed level of glucose than boys. That result also we could see. Yes.
Thank you, sir. The question was from Chai and Vishwa, sir. Thank you for your question. If no more question from a participant side, let's conclude our session.
Yes.
So we got one more question. How do
Yes.
sample evaporation and contamination from skin surface affect measurements?
Can you repeat it once more?
How do sample evaporation and contamination from skin surface affect measurements?
Yes, very good question. Yeah, that affects because the evaporation of your sweat will happen, but not the sensor. Sensor is stable. The sweat will be easily evaporated, but you need only very small amount of sweat of microliter level, not even milliliter. We need only microliter level sweat is only needed. But contamination definitely happens, because that is what I said, after sweating, immediately after sweating, if you do the testing, and after getting the sweat dried, then the level of crystallized salt and crystallized organic acids in your sweat will be more. You can see that after you sweat and after it is getting evaporated, your sweat is settling down on your skin pores, and then there the concentration of the contaminant will be more. So that will give a different value. But the interesting thing is that glucose level will not change. Glucose level will not change. What is changing is the level of different contaminants, like different organic acids and salt. I have the goodness about our sensor is that these organic acids and salt are going to unaffect the sensitivity of our. That is what I have shown in one of the slides. They are not going to affect the sensitivity, but during different times of meals and different times of an year, definitely they are going to. Yes. Any other question? I expect more questions from youngsters, because if I don't know the answer, that will give us a chance to study more, because we are all students. We are also students. That's no problem. Please. Sometimes you think that your questions are senseless. No, the questions are not senseless. All questions in this world are sensible questions. This is what we feel. Okay.
Motivating all the participants to questions.
Hello.
Hello, sir. Can you hear me?
Yes, yes.
I think there is a network issue in Anju, madam.
Yes. So all the questions are over?
Yes, sir. There is no more questions in the chat box.
Oh, okay. Okay, great.
Yes, sir. Thank you very much, sir, for delivering such an insightful and thought-provoking sections on tailor-made materials for flexible biomedical sensors. Your deep knowledge, clarity, and practical examples have significantly enriched our understanding of this innovative area. The real-world applications you shared have truly inspired us and highlighted the tremendous potential of flexible biomedical technologies. On the behalf of the organizing committee, all participants and the entire FDP team, we sincerely express our gratitude to Dr. Surendran KP for taking the time to join us today. Your valuable contributions has greatly enhanced the quality of this program, and we feel privileged to have benefited from your expertise. Thank you, sir. Thank you once again.
Thank you so much for giving me an opportunity to speak with you. Okay, great. Sometimes we will meet again. Thank you very much.
Thanks.
Bye. Bye.
Thank you, sir.
Thank you, sir. Thank you, Aditya.
We would also
like to extend our heartfelt thanks to all participants We would also like to extend our heartfelt thanks to all participants for your enthusiastic engagement and thoughtful questions, which made the session even more interactive and meaningful. Forward to your continued participation tomorrow, the final day of our faculty development program. The FDP will begin at 2 p.m. and will feature 3 enriching sessions. Following 3 sessions, an online test consisting of 25 multiple choice questions. All participants must attend the exam to receive the certificate. Your presence and active participation were essential to make the final day meaningful and successful. So we encourage everyone to join and be part of the concluding session. Thank you once again.
Hello, madam. Am I audible, madam? Hello.
Yes,
Hello.
yes, sir.
Madam, may I know
Yes,
what is
sir.
the procedure for test, madam, for tomorrow's test assessment? Whether we are going to get any Google form or any other?
Yeah, sir. In between 7 p.m. and 8 p.m., we will provide the questions as in the Google form. It will contain 25 multiple choice questions.
Means
You can
after
answer
valedictory, no,
within
madam. After
8.
valedictory. After valedictory, no, madam.
Yeah, sir. Yeah,
Okay,
sir.
madam. Thank you.
Yes,
Thank you.
sir.
Thank you,
Yes,
sir.
sir. Actually, you need to you need to attend the test through ATAL portal.
Sir, if it was in ATAL portal, the timing was fixed, no, sir. We cannot go beyond that time, no, sir.
Yes, sir. Yes, sir. 7 to 8. The time.
Not clear,
whatever it may
but
be, you please confirm in advance, sir, about if it was in ATAL portal, whatever may be the timing. If you confirm by at least by afternoon, then it will be good for us, sir. Thank you, sir.
Yes, sir. Yes, sir. We will inform. Sir. 7 to 8
Okay,
tomorrow.
thank you.
Participants need to attend the exam through their individual ATAL portal.
Okay, through ATAL portal we need to go, sir. Okay.
Yes, sir. Yes.
Okay. Thank you, sir. Thank you.
Thank you.